Our last presentation today is from a graduate student here at Pitt, Max Wynn, who's going to be providing us some talk on his work on utilizing terrestrial photogrammetry to model landslide features. So Max, the show is yours.
All right, thank you very much. Share. Oh, probably go to the beginning. All right, is it sharing?
Yes, we can see you. You're good, Max.
All right, so thanks again for the introduction. Again, my name is Max Wynn, and I am a second-year student pursuing a master's degree in GIS remote sensing here at Pitt. And before I get started, there are just a couple of things I'd like to give out. First and foremost, to my project advisor, Dr. Anthony Yannicchioni, who is kind of running my project for the master's program I'm in, and has also helped put together a lot of this iRise stuff. Some more thanks to Dr. Julie Vandenbush and anyone else I'm forgetting who helped to put this together. And then additionally, some of the academic advisors, Dr. Dan Bain and Dr. Bill Harbour and Dr. Mike Ramsey, who just kind of, you know, I wouldn't be here without all their kind of leadership and direction. And then also, before I get started, if you enjoyed my presentation and you think it's interesting or could be helpful to any sort of research that you're doing, I would also recommend to go check out Dr. Christoph Mertz's talk, who kind of goes into some more detail and more challenging processes, I believe, involving these methods. And then also a PhD in geology, Tyler Rohan, goes over a similar method to mine. So with all that said, let's get into my talk, which is utilizing terrestrial photogrammetry to identify and track landside geometry and potentially movement. So to start, what is photogrammetry? Well, it's the science of making measurements from photographs. And so conceptually, pretty much what you're doing is you're creating a 3D model from a base of, from a collection of photos that you kind of methodically take over an area of interest or an object that you're trying to get like distance and volume measurements from. And so what it does is it, with all these overlapping photos over a particular area, it pieces together all these targets and objects in your area of interest, and it kind of uses like a trigonometric function to tie all this together and to give you hopefully an accurate representation of the features that you're trying to model. And so there's two common types of photogrammetry, one being aerial photogrammetry, collected from either some sort of aircraft or a drone. And then there's terrestrial photogrammetry, which is the method that I'm going to be going over today, which is taken from some sort of side-looking instrument, like a survey grade camera, or could be simply from a smartphone. And so what are the sort of the pros and cons of using terrestrial photogrammetry as it relates or compares to aerial photogrammetry? Well, it's pretty cost effective. And some of the reasons for that is, you don't have a need to make any investments into, an airplane or a flight or a drone. So if you don't have that equipment, you don't have to make that investment. And then you can also save a lot of time on like flight plans, like permitting and approvals that you need to get with if you're flying in a public space. Also, using terrestrial photogrammetry, you can get into spaces that these instruments and vehicles can otherwise not. Say if you're like under a tree canopy or under a bridge structure, that would be better suited for the terrestrial method. And then, as I mentioned, all you might need is a smartphone if that's all you had. So it's a relatively low cost or investment. And a con would be the spatial scale is limited. So if the area you're trying to model, like the landscape, is vast and can't really be detected from one vantage point, then it might not be suited. And you might need to make the investment for aerial photogrammetry. All right, so another point I just want to kind of get across in my talk is just kind of like the cost-effective aspect of it. Because if you think this is like a method that would be helpful for something that you want to look into, or a project or research that you have, then you know, it's relatively cost-effective, and you can probably find the right software for you. I personally, for mine, used Agisoft, and it was a relatively low rate. And you know, if you can't find a free software and you need to pay for it, make sure you look into like educational licenses, which, you know, students and professors are often you know, eligible for. But there's also plenty of open source software out there. So if you research, you know, their abilities and what you can do, you can often find a free version of what you're trying to do. All right. And then once you've pinpointed the necessary software that you know, that can do what you need, you're also going to have to consider computing power. So you're probably going to need something that's, you know, probably 32 gigabytes of RAM and a really good graphics card to be able to handle this kind of data, because it's often the processing gets really complex, and you need something that can handle that. So if that's not available to you, I would just say make sure that you meet with an academic advisor, someone in your department or somewhere in the school, to see, you know, where labs exist that will be able to take on that kind of processing. Okay. All right, and so let's actually get into the process of creating the photogrammetric model. So this is just a snapshot, couple images of my study area for the model I was trying to create. I chose this area because it's kind of like a barren site that, you know, sort of resembled a landslide area. Me and my advisor, we originally set out to try to model some landslides in Pittsburgh, but once COVID hit, it kind of just stalled progress and some of like the original aspirations that we set out to do. So I just resorted to using this area, which was in my backyard, essentially. And so take notice to some of the targets that are in here, and like the pit that's in this images, because that's all going to be important for the process of creating this model. And so here is a video, actually, it's a short, like, minute-long video of just the resulting model. Just wanted to give you a good look of it, you know, largely just because it's a pretty cool deliverable, and you can see like how detailed it comes out and resulted. But also just to give you an idea of like what this looks like in the software. You know, if you're familiar with any type of GIS or like CAD software, it uses like that similar layering concept of like importing all your images into a contents pane, and you're able to play with those images and everything and such. And so you can see those targets and all the images on the bottom there. And that's essentially all I was trying to let you see with that slide. Okay, so next we'll get into the workflow of creating these models. There's several steps involved with this method. And as you can see here, this is like, you start with aligning the photos, then you go into building a cloud, scaling the model, aligning two different models. So in this software, they're called chunks, and then building a mesh and building a DEM. And as you can see, those blue squares there are all of the photographs of where you're standing when you take the photograph. And you're going to want to take it in like a sort of a methodical way, you know, so there's plenty of overlapping between your images. And so this is that first step of aligning the photos. You import all of your images into the software, and it puts them into that workspace pane. And then you align your photos, which is actually just you know, a simple geoprocessing step where you just import all the images in, then you align them. And then it takes everything, all the targets and areas in the photos, and it sort of like computes them and ties them together. It gives you this this first output of what the software calls like a sparse cloud. It may look pretty dense, but you'll see it builds an even denser cloud in the next step. But basically, you can see how it pieced together and gave you the groundwork for this model. And so from there, you build a denser cloud. And you can see here just one of the snapshots of the targets that I put into this study area. That snapshot alone probably has several 100,000 points just in that area. So these outputs get pretty big pretty quick. And then the next thing you're going to want to do is to scale the model. And so take notice to the kind of layout of the targets that I laid down in the study area. You're going to want to deviate these targets so they're not in a straight line so that you get accurate scale in all 3 dimensions. So as you can see, like 0.4, I stepped over to the right, and then 0.5 was placed in that pit, giving it a 3D dimension. And that's basically, considerations you're always going to need to take into when you're setting up a study area. And then here's just you're creating the type points for all of your points. So what you do is you actually can just go look at each individual image that created your point cloud. You can set a type point onto your target, and the software actually links all of the images, recognizes where you're trying to place all the points, and any time, say, like one of those targets appears in a photo, it tries to locate that type point that you're creating. And then you can manually go through each image and make sure that the point is located properly. And then you just, with this method, you set the distances that you place the targets apart. So in my case, I placed them all 10 feet apart, and that is essentially how you scale the model to real life size. And ideally, in an environment where you're like modeling a landslide, you're going to have access to survey grade equipment where you can get somewhere to like a centimeter's worth of accuracy, and that would be how the model would be scaled. But in this method, not having that equipment on hand, by setting up a network of points with known distances, that is how you can scale your model. I did the same thing up to this point for a second set of photos where I actually placed boxes into the photos. And these are the features that I was trying to identify between the 2 different models to see how accurately I could represent their size in the models. So you align the chunks based on the targets placed in both photos. And that was essentially the method for my analysis. And then the next step is building a mesh, which is just like a triangulated surface representing a terrain, which is just a step in the software that you need to do in order to get a digital elevation model, which is another type of file format that is helpful in doing a lot of different geoprocessing and geospatial analysis. So as you can see here, these are the 2 different models. One of them, you can kind of see the boxes in the model. All right, and so getting to some of the results, this is a kind of a common geospatial analysis is getting a change detection surface. So what you do is you take the second set and then you subtract the first model from that, and then it results in a change detection surface, which you can see here. I was able to identify some of the boxes in my survey, being the Dell box, the New Balance box, and the Nugs box. And you might notice with the legend, some pretty like a wide range of results, and a lot of that was due to the outer edges of the survey and not having as much photo overlap on the edges. So that gave a lot of the was kind of attributed to the wide range in the results, which I do recognize. And then this is just kind of a rudimentary analysis of the size of the targets in the model compared to their real life size. So you can see here all of the larger bars are the real life size and volume, and then the models are all kind of consistently underestimate the size of the target, but I was happy with the result that they were consistently smaller. So, all right, but how does that kind of all tie into the landslide topic of this seminar? So like I said, we originally set out to model some landslides in the Pittsburgh area to see if we could just get accurate dimensions in the model for these landslides, and to potentially, if we could revisit the same site, collect the same points, if we could detect any change. But some of that wasn't available to us, but that is essentially what you could do with this method. If you could get out to a site, take some photos with your smartphone and get some ground points, then you could hopefully detect changes between models. And here's just a couple more images of the landslide. This is in William Street, and it is near the Liberty Bridge on the south side. You can see that here. And then finally, just a video where we were able to create a model for this area, but we just weren't able to get it geolocated. But I just wanted to get the point across that this was just a model created with a smartphone, just on a quick visit to the landslide site. That's all I show. All right. And that concludes my topic. Just sort of to summarize everything, some of the main points. Photogrammetry offers an effective way to characterize landslide geometry, things like elevation, the slope, the volume of the landslide area. And by revisiting the same site and taking sequential surveys, you can potentially track sites that are prone to landslides to see if any movements are occurring. And the reason you would do that, maybe you can assess what kind of mitigation techniques or preventative techniques you could take to a landslide site. Maybe if you see you need to insert any fill to any area that's been reduced, or if you need to remove fill, those are good applications of this technique. So that essentially concludes my talk, and I'll be happy to field any questions from anyone.
Thank you, Max. Any questions for Max on his presentation today?
Yeah, actually, Dr. Sachs, I was wondering, if you were interested in this kind of stuff, what kind of classes would you want to kind of take?
So I know there's some good ones in geology. There's some remote sensing courses in which they at least go over some of the technology, and they're definitely happy to allow you for your projects to look at some of this data. Some of the stuff I did was for those classes, and they go over some of those topics. I'm not actually familiar with any classes in the engineering program, but I'm sure there are some, and hopefully someone can take that question and be able to answer it.
Thank you.
Mm-hmm.
Thanks. I had a couple
Max?
questions. Go ahead.
Oh, go ahead, Steve.
I was just going to say we had a couple questions pop into the chat.
Yeah, I think I need to.
Yeah, a question from Larry on what software was used to make the Keller Enhanced Surface Map?
That was in Agisoft as well. That was just the straight output that it created. I also used ArcGIS to actually work with the outputs. So that's the cool thing about all this software. You can take an output from one, and that you might be able to put it into something else to further use the outputs that it created. So I used Agisoft, was the program that created all of those different outputs I was showing, and then ArcGIS was also supplemented to help out with some of the analysis.
Awesome, thanks. And then one more question in here about when you were using the software, did you have any setbacks or were there drawbacks using it, or anything you could have done to, you think to make the program a little better to use?
Some of the drawbacks, I mean, definitely just learning how to set up your the site and like how you're collecting and taking the photos, like what kind of alignment and what kind of setup you want to do. Like I learned that like going around definitely going around the study site resulted in some more erroneous results. So I just stuck with the one pass on one side. So with a little more time and more processing power, I would have hoped to improve there. So that was one setback. Just learning the kind of local method without just being able to simply input like coordinates for control points, and having to locally register both of these sort of local scans or models. That was a little bit of a learning curve and just trying to get that right. So those are probably two areas.
Awesome. Thanks. Yeah, any other questions for Max? Okay, well, I thank everyone.
Hey, Steve.
Yeah.
Steve. Yeah, I did have one more that maybe Max could comment on. I know that this is sort of focused on landslides, but something parallel with embankment and the undermining. Have you used this technique at all in that? I know you've been working on the undermining of I-70, and has any of this been used with that, and how?
No, so we haven't used any of this kind of method there. For anyone that, everyone's probably wondering what we're talking about. We did a project that used LiDAR to detect surface movements over a coal mine. So that's one thing that I had been interested in, is like comparing, if you could compare this method to movements that were detected by LiDAR, just to see if there's any comparison, like accuracy and precision of these two different methods. I would be interested to do that, but it's not something that we have applied to that project. No.
Thanks.
Mm-hmm.
Awesome. Thank you very much. So I want to thank everyone for joining us and attending session C today for the last landslide seminar in the series. What we're going to do now is all kind of head back over to the main room. I think we might have finished a little bit earlier than some of the other sessions. So yeah, we'll just sit tight for a couple minutes while everybody else kind of wraps up their sessions. And we'll loop back around and get summary remarks from Dick Gray. So thank you, everyone, and have a... Yeah, go ahead, Julie.
Hey, Steve, yeah, maybe if there's anybody on that has some, new and exciting activities that they're performing with regards to landslides, we might have some time to discuss that now until everybody's ready to rejoin the room.
Yeah, certainly. Yeah, if anybody has anything they want to chime in, have a discussion about, this is a great place to have it.
Steve, this is Stan Mahalik.
Yes, Stan.
Just a comment for Max. When we're doing our scans using our drone, we use a ground control point from a company called Aero Points. These are GPS units that you place on the ground. You're supposed to use up to 10 of them, and they gather GPS data, latitude, longitude, elevation, and then they're included in your survey. And then when you process them, and we use Pix4D, you can georeference everything to those ground points then. Just a useful tool that he might want to look into as he moves through his studies.
Yeah, definitely. And so yeah, I mean, that was one thing I wish I had access to. And then just kind of COVID hit. And so that is one thing I recognize, would help these models. And, if you could actually locate these, that would be, fun experience to get, and something I'm interested in just generally. Thank you.
Okay, yeah, thanks. Anything else anybody wants to share? Okay, well, yeah, Julie?
Yeah, I guess I do see that Beverly's on. I hate to put her on the spot, but is there anything going on statewide right now that I think she had mentioned before they were trying to build a database, or any other activities that might be going on statewide with respect to landslides that she could share with us?
I'm sorry, I don't have a whole lot of information. Dennis and the geotechnical section are continuing to work on the geotechnical asset management program, and coming up with, I guess at this point it will be a spreadsheet, to have our districts and have a centralized place to enter their landslide information. Other than that, we're looking at some research with Penn State for AI, and I'm not sure what was the outcome of the last meeting that we had the other week as far as research.
Right, great, thanks. Beverly was referring to the brainstorming session that iRise held, and I know there are a lot of great ideas brought up at that point too on landslide activities. So I guess we have things to look forward to in the future coming out of iRise in this area. Thank you, Beverly. Sorry to put you on the spot like that.
No, that's fine. Thanks for letting me give you the status.
So I think, are we ready to rejoin, Steve?
I think so. Yeah. So at this point, we'll wrap up session C. We'll all migrate back over to the main session for summary remarks from Dick Gray. And thank you, everyone, for your time today.